Hello, my name is Jeric, and I'm going to show you how atmospheric refractions occur. What is atmosphere? The atmosphere is the blanket of gases which surrounds Earth. It is held near the surface of the planet by Earth's gravitational attraction. The atmosphere is made up of mixtures of gases, mostly nitrogen, oxygen, argon, and carbon dioxide. It reaches over 500 kilometers above the surface of the planet. There is no exact boundary between the atmosphere and outer space. Atmospheric gases become thinner the higher up you go. The atmosphere just keeps getting less and less dense until it bends into outer space. The atmosphere is divided into 4 layers based on the temperature: the troposphere, stratosphere, mesosphere, and thermosphere. What is refraction of light? Refraction is the bending of a wave when it enters the medium where its speed is different. The refraction of light when it passes from the fast medium to a slow medium bends the light ray towards the normal to the boundary between the two media. The amount of bending depends on the indices of refraction of the two media and described quantitatively by Snell's law. Snell's law relates the indices of refraction and of the two media to the direction of propagation in terms of the angles to the normal. Snell's law can be derived from Fermat's principles or from the Fresnel equation. Before to proceed in the atmospheric refraction, we will watch first the video experiment. Do you know what is common to sparkling of diamond and twinkling of star? It is refraction, the bending of light at the interface of two media like air and glass or air in the water. So, let's see refraction. We have water, glycerin, empty glass, and pencil. Pour some glycerin in the glass. Then, pour some water over it. As you can see, glycerin is being heavier than water. That settles at the bottom. And glycerin and water from two distinct layers place. Then, place the pencils like this. Now, look at the pencils from the side of the glass. What do you see? The pencil seems to bend at the point where water surface meets, and also where water meets glycerin. This is because light travels at different speed at different media, as the light beam passes from air to water and it slows down, and so it appears to bend at the boundary. So when light moves through multiple media, it bends every time it moves from one media to another. So what does this have to do with twinkling of stars? Any guess? The different layers of atmospheres have different densities and composition, And so, multiple refractions of light happens as light travels through these layers of atmosphere surrounding the Earth. The refraction in random direction due to the fluid nature of atmosphere and wind makes the rays enter our eye at certain moment only. This leads to sometimes us seeing the light and sometimes not. Our brain interprets the situations as twinkling. What is atmospheric refraction? Atmospheric refraction is the deviation of light or other electromagnetic wave from a straight line as it passes through the atmosphere due to the variation in air density as a function of height. This refraction is due to the velocity of light through air, decreasing with increased density. Application of atmospheric refraction. The apparent random wavering or flickering of object seen through a turbulent stream of hot air rising above a fire or radiator. Twinkling of stars. Advanced sunrise and delayed sunset. Apparent flattening of the sun's disk at sunrise and sunset. The stars seems higher than they actually are. Advanced sunrise and delayed sunset. The sun is visible to us about 2 minutes before the actual sunrise and about 2 minutes after the actual sunset because of atmospheric refraction. The time difference between actual sunset and the apparent sunset is about 2 minutes. The day is longer on Earth by about 4 minutes due to atmospheric refraction. Twinkling of stars. The twinkling of stars is due to the atmospheric refraction of the star's light. While passing through the atmosphere, consisting of layers of different refractive index, the light from the star undergoes refraction continuously. Since upper layer has a lesser refractive index than the lower one, starlight bends towards the normal due to which the star's position appears slightly different from its actual position. Also, the physical condition of the atmosphere keeps changing. The apparent position of the stars fluctuates, which gives rise to twinkling effects. Why do the planets not twinkle? As compared to the stars, the planets are more closer to the Earth. We can consider planets as collections of large number of point-sized sources of light. Net variation in the amount of light reaching our eye from all the point source will average out to be zero. Thus, on the whole, the brightness of the planet always remains the same and does not appear to twinkle.